Hello. Today we are simplifying factorable rational expressions. Rational means that it can be written as a fraction. And today we're going to be applying a rule that you know about fractions, which is that they need to have like denominators in order to add or subtract them. We're going to apply that to expressions that have variables in them, so like 6 over x minus 1 instead of just 6 over 5. The rules still apply here. So if you look at our two denominators, we've got a fraction that has the denominator of x minus 1 and a fraction that has a denominator of 4. These are not the same as each other, so they're not like denominators. But what that means is we can actually do something really easy here. On the fraction on the left, I can multiply by 4 over 4. After I multiply by that, the denominator will now have a 4 in it. And on the right, there's already a 4, but what there's not is an x minus 1. So I can multiply this fraction by x minus 1 over x minus 1. There's still some math to do here, of course, but you'll notice that the denominator on the left now has both a 4 and an x minus 1, and the denominator on the right also has a 4 and an x minus 1. So after we simplify this, we are going to have some like denominators. For the first fraction, 6 times 4, of course, is just 24. There's not a lot going on here. And in the denominator, I'm going to write 4 times x minus 1. You could distribute that, of course, if you wanted to, but I'm going to leave it like that. And then in the next one, in the next fraction, we do have something that needs to be distributed. So we've got a 5x times x minus 1. So I'm going to write plus 5x squared minus 5x. And then this is over that same denominator of 4 times x minus 1. The last thing we're going to do here is now, of course, combine these. This is going to equal one fraction with that whole same denominator, so 4 times x minus 1. And all this is just being combined in the numerator, but I don't see any like terms, so I'm just going to write that numerator in standard form. So 5x squared minus 5x plus 24. There were no like terms there to simplify it all. In our next example, it's the same basic idea, except our denominators both have algebraic functions in them. So in the first fraction, I need to multiply by x plus 3 over x plus 3. That's going to give me, well, let's see, we need to distribute that 10 to both of these. So this is going to give me 10x plus 30 over x plus 3x minus 4. Plus the second fraction, we need to multiply by x minus 4 over x minus 4. And we're going to need to distribute that 5 in the numerator as well. So we're going to have a numerator of 5x minus 20. And then our denominator is going to be x plus 3, x minus 4. And of course, that's the same as the other fraction, which is why we did this. So to finish this off, we know we're going to have one big fraction with the denominator of x plus 3, x minus 4. Again, you could FOIL that out if you wanted to. And this time in the numerator, we are going to have some like terms. So we've got 10x plus 5x, which is 15x. And we have 30 plus negative 20, which is 10. That is it. We have now turned these two different rational expressions into one big fraction.